Quick question, technical specs of the computer. What type of Intel processor and what type of motherboard North Bridge?
It's a Q6600. It has DDR2. The processors are 2.4 gigahertz each. Each of them have 1 megabyte of cache. Beyond that, I got it for Christmas, so I don't really know.
So what is the restraint?
It's Santa
Yeah.
Core 2 Huang,
Yes.
which shares a single, which actually shares a paired bus.
Right.
Whereas if you would had
A Xeon or something.
or if
You get
use
two
the
buses.
workstation motherboard with the same processor on there, it'd be able to give you
Right.
two independent buses.
Yeah, if I'd known that there was this memory slowdown, I would have asked for a Xeon, but I didn't.
One of the other things is
That's this next year.
Yeah, exactly.
one of the things that Windows has problems with is dual channel pairing over over a system bus.
Yeah, it was bad.
Tell us about your teamwork.
He does all of the crazy math, and I
did more
do.
of the model, and
Yeah.
she wrote the code.
How much of your, just, yeah, to that point, how much of your, what you've got there is model? How much is non-model?
In the code,
Yeah.
Graphics.
You know,
It-
graphical stuff.
graphics is in a different file. This is, I have, in terms of model, there's molecule-molecule collisions.
Molecule object.
And then there's Boltzmann distribution, and that's not very much at all. Most of it is stitching it together and stuff.
You're just writing a JPEG?
I'm writing GIF images, yeah.
Okay.
And I have a separate file that has all the image writing stuff in it.
Okay.
So this is about 2,000 lines of code, and the model is not as much. So like mol collide.
So what stopped you from asking for time on the supercomputers?
Well, I really wanted to try the multi-core because that hasn't been done before. I haven't seen people running this on multi-core. And I mean, I could have, and people run it on the supercomputer all the time, and I really wanted to see how it ran on the multi-core.
You guys are throwing out the best quotes.
Absolute marketing campaign for Craig. See if you can answer this question without touching your mouse and keyboard. How much of this is the multi-threading stuff? If this was a single-threaded application, how much simpler would it be?
There's 20 lines of code dealing with multi-threading. I'm not kidding, really.
Oh, but that's because it's shared memory. It's shared memory.
Right, exactly.
Makes it simple.
Yeah, there's no message passing like that.
The accommodating boundaries, is that new since the final report?
Yeah, that's something we put in
Yes.
since the final report. In the final report, all our boundaries were specular with gamma equals 1. And since then, we've added in both the gamma for the specular as well as accommodating boundaries.
Because that was all to do with how much energy is transferred to the object, and that was what that was about. We found out that was why it happens.
Right. And so how did that improve your results any? Did you see?
Well, it's more realistic.
Right.
Well, when you compare it to, because it's not going to be a perfect reflective collision even in space. So this makes our model more realistic. Even when you're in space for several weeks, like I said, it's only 40% specular. So.
And you saw the difference in the picture a bit between, so that makes a big difference.
Does low orbit versus high orbit have anything to do with how fast that sheds the?
That has to do with like altitude you're at and density. So we reset parameters if we were at a different altitude. But that, like, whether it's specular or accommodating depends on whether it's outgassed or not. So.
All right, so just a clear question because you have also, you had talked and mentioned that you could add the ionization plus molecules, that is spinning and interacting, all of that.
Mhm.
But could you do just, because one of the nice applications I'm working is the gas of electrons. And that's, it's treated like a ramified, gas. And also neutrons are treated like that too, and they respond to the same equation. Can you consider all of those applications?
Yeah,
Might.
we can apply this to different altitudes, densities, and stuff, but we have to change what we're modeling in order to ensure accuracy.
If we put in chemical, like rotational collisions and maybe chemical reactions, that would change our molecule-molecule
But not
collisions.
by a tremendous amount, like,
So right now we're assuming two molecules are neutral and they just collide.
but
And
they have
don't
different
lose
masses.
mass. Yeah, we don't lose any mass or momentum in the collision.
So how much computational effort would that take if you were putting in the rotational and the charge balance and all of those sorts of things? Does that add huge amounts to your code as you see it right now, or are those sort of simple augmentations?
That would make the molecule-molecule collision function about twice as long, I'd say. It'd be about twice as much. I mean, I'm just guessing, but I'd say that'd be about twice as much in terms of that. So that'd make it run better on the quad core, though, so might want to do that.
Okay, one more question.
If your goal is to keep all the cores busy, yeah.
Sort of lighten up on that bus. You know.
Yes? Any question?
Well, I'm not sure it's really appropriate, but I'm just kind of curious about how much, if you understand how much the cache, you have a chunk of cache on each core, and how much that's actually helping, and to do these augmented things, could that algorithm, or could the way you do that, could that potentially help by not actually going out to the bus all the time?
Right, well, that's why I have my data structure the way it is, so I can keep a whole bunch of molecules in the cache.
Copying the thing down, doing
Right, and I've also tried to make each molecule have as little data as possible, so I can store as many of them as possible at the same time. So, I mean, I've done all sorts of stuff to try to get things on the cache. And this, I mean, you saw the improvement I got since the final report.
So it's you're kind of using XY coordinates to determine where this CPU does it, where that CPU does it.
Right, and we can adjust that too.
So.
So.
Okay, thank you very much.
Thank you.